Alright, welcome back. So now we're going to be looking at determining the scale factor, and to do this it's really easy. All we have to do is start out with our value and then compare it with our scaled or actual length. So our scale on our drawing shows 4. It shows 4 centimeters, it represents 40 centimeters, right? So this is the ratio of the drawing to the real world, and we know that we can divide this or make this simpler. So if we divide both parts by 4, we get 1 to 10. So when it's asking you for the scale factor, you are going to put it in its simplest terms. For B, we have 80 centimeters, so 4 to 80. Again, we're going to divide by a common factor. The highest common factor between both of them is going to be 4. So it becomes 1 to 20. And finally for C, we have a 1.2. So 4 to 1.2 meters. But because we don't really want it in that, and we can't use it because ultimately it's not the same units, we do need to edit that and make sure that they're in the same units. So 1.2 meters will be 120 centimeters. Again, divide both sides by 4 and you get 1 to 30. Alright, let's look at 6. So for 6A, we have 5 meters, and the scale factor is given, is what we are trying to find. So we have the actual distance, we have the scale distance, so it's going to be 5 meters to 800 meters, right? Again, divide both sides by highest common factor. In this case, that's going to be 5. So 1 to 160. Alright, let's look at B. We have 5 meters, 1.5 kilometers, so we need to put that into meters, so 1500 meters. Again, divide both sides by the highest common factor, which is going to be 5. And finally C, we have 5 being compared to 3 kilometers, which needs to be in meters as well. And we're left with dividing both sides by 5. So if we divide the first by 5, we get 1, and the second part by 5, we get 600. Alright, so finding the scale factor can be quite easy. Just remember that you need to have them in the same units before you start. Alright, that's it for this video. Hope it was helpful, and I will see you in the next one.